A 3,000-ton cargo ship cuts through the lush, green karst mountains of southern China. Below it, ancient rivers wind through untouched forest valleys. But this ship isn't following a natural waterway. It's sailing through a man-made canyon carved straight through solid rock, without diverting a single drop of water from the region's protected ecosystems. This is the Pinglu Canal, and it is one of the most jaw-dropping construction projects ever completed in East Asia. Here are the numbers that will stop you in your tracks. It stretches 135 kilometers end to end. It was built in less than 4 years. It cost $10 billion. And when fully operational, it will move more cargo every single year than the entire Panama Canal. Almost every single piece of it was engineered and built by one country, China. But before you ask how, you need to understand why. Let's start from the very beginning. For decades, China's southwest inland provinces were stuck in the past, strangled by a geographic bottleneck. Every day, thousands of shipping containers full of goods, raw materials, and farm produce arrive at inland ports across Guangxi, Yunnan, and Guizhou. But here's the problem. Getting those goods to global markets used to be a logistical nightmare. The only existing route forced ships to sail 1,200 extra kilometers east along the Pearl River to Guangzhou's ports, adding weeks of travel time and millions in extra costs for every single voyage. Think about what that means for a region trying to grow. Smallholder farmers couldn't get their fresh fruit and vegetables to overseas markets before they spoiled. Local factories couldn't get cheap imported raw materials fast enough to keep production lines running. The whole inland economy was held back, all because the region's waterway infrastructure was stuck in the past. China's southwest needed something bold, something that would shatter that geographic bottleneck forever. In 2022, China's Ministry of Transport and Regional Authorities unveiled a plan that was almost impossible to say no to. Using centimeter-precise satellite mapping, aerial LiDAR scans, and full 3D digital twin modeling, engineers mapped every meter of the route, accounting for every hill, every river, and every protected ecosystem along the way. The goal was simple on paper, but almost unbelievable in reality. Build a 135-kilometer sea-level artificial canal with 3 massive ship locks that can handle 10,000-ton cargo ships in under 4 years. To put that in perspective, the Panama Canal took 10 years to build with 10 times the workforce, and it's only 30 kilometers longer. Before a single ton of rock could be blasted, before a single ship lock could be poured, engineers had to deal with one of the biggest, most invisible challenges of the entire project. The first battle wasn't against the 60-meter-high mountain ridge they had to carve through. It was against the ground itself. The canal's route cuts through miles of soft, water-saturated mud and silt, ground so unstable it would shift and sink under the weight of even a small truck, let alone a 10,000-ton ship lock. To solve this, engineers used a clever, surprisingly relatable trick. When soft silt gets mixed with just the right amount of cement and compacted, its particles lock together and turn solid, almost like adding a small amount of egg and water to loose breadcrumbs to make a firm, stable crust. Then came 40-ton heavy-duty compactors that rolled back and forth across the ground 24 hours a day, like giant kitchen rolling pins pressing dough into a perfectly flat, even sheet, squeezing out every last air pocket and locking the soil into a foundation strong enough to hold 50-story buildings, let alone a canal. Now, here is the part that will genuinely make your jaw drop. The heart of the canal is the Manning Ship Lock Complex, the highest water-conserving ship lock in the world. Each of its 3 lock chambers is 300 meters long enough to fit 2 full football fields end to end. The steel gates that seal each chamber are 47 meters tall. That's about as tall as a 15-story residential building. Each gate weighs 3,200 tons, as much as 530 full-grown African elephants. To move these colossal gates, engineers built hydraulic systems so powerful they can open and close these 3,000-ton steel doors in less than 5 minutes, with precision down to a single millimeter. But the real magic isn't just in the size, it's in the micro details that make this canal work for 100 years. Those 3,200-ton steel gates don't come out of a factory ready-made. They start as 100-ton slabs of high-strength steel, heated to 1,200 degrees Celsius, glowing bright orange like the coals in a backyard barbecue. At this temperature, steel doesn't shatter. It flows. It bends. It's fed through massive rolling machines that work like a pasta press for metal, squeezing the steel into perfectly flat, uniform plates with a thickness tolerance thinner than a human hair. Then, robotic welders work around the clock, joining these plates together with 30 kilometers of welds, every single one inspected with X-rays to make sure there's not a single flaw that could cause a leak 50 years from now. And it's not just the steel. The canal's bed is lined with 2 million cubic meters of reinforced concrete, enough to build a 2-meter wide sidewalk all the way around the entire Earth. Every batch of concrete was mixed to a precise formula, like a baker mixing cake batter for a world-class competition, adjusted for the temperature, humidity, and even wind speed on the day it was poured, to make sure it cures perfectly, no cracks, no weaknesses. When the first 10,000-ton cargo ship sailed the full length of the Pinglu Canal in 2026, the journey from Nanning's inland port to the Beibu Gulf open sea took just 22 hours. The old route along the Pearl River, it could take more than 14 days. That is not a small improvement. That is a complete transformation of global trade routes. The numbers tell the full story. The canal cuts shipping costs for inland businesses by up to 40%, eliminates 1,200 kilometers of extra travel for every voyage, and has a designed annual throughput of 1.8 billion tons of cargo, more than the Panama Canal's total annual cargo volume in 2025. Remember the farmers and factory owners we talked about earlier? This is what the canal means for them. Mango and lychee farmers in Guangxi can now get their fresh fruit to Southeast Asian markets in 2 days instead of 2 weeks, meaning they can sell at a premium, no more spoiled produce going to waste. Electronics factories in Guizhou can get imported chips and raw materials in days, not weeks, keeping production lines running 24/7 and creating thousands of new local jobs. A small business owner in Nanning can now order goods from Europe, have them unloaded at the Beibu Gulf port, and delivered to their warehouse the same day. This canal didn't just move water and ships. It unlocked an entire region's economic potential for millions of ordinary people. Is the project perfect? No. The canal came with significant environmental challenges, requiring strict, round-the-clock protections for local fish species and protected ecosystems along the route. The $10 billion price tag meant taking on large-scale infrastructure debt, and the full economic benefits will take years to fully realize. But in terms of the scale of engineering, the speed of construction, and the sheer ambition of redrawing a region's geographic map, it stands as one of the most remarkable civil engineering feats of the 21st century. If you made it this far, you just took a journey through one of the most ambitious infrastructure projects in modern history. You learned how engineers beat impossible odds, rewrote the rules of civil engineering, and unlocked a region's future, all without sitting through a single boring engineering lecture. That is what this channel is all about, breaking down the world's most incredible feats of human ingenuity in a way that makes you feel like you're right there on the construction site watching history happen. If that sounds like your kind of content, hit the subscribe button and turn on notifications so you never miss our next deep dive. If you could build one game-changing infrastructure project anywhere in the world, where would you build it and what problem would it solve? Drop your answer in the comments below.